Hi everyone, and welcome to another video of the SAFI webinar series. In this video, we are going to have an overview of plate attributes. The attributes that can be changed for plates are the plate name and color, the section, and the plate type. There are three plate types which include thin, no shear deformation, thick, with the shear deformation, and membrane, which has only axial and shear deformations. We can also edit offsets and the connectivity. Without further ado, let's start our demo. We can edit the attributes of one plate by double-clicking on the plate. We can also edit the attributes of a selection of plates by selecting the plates and using the command plate attributes. In the plate attributes dialog box, the user can specify a name and can also change the color of the plate. We can also assign a section. If the section is already created, we can select it from this list. If not, we can create a plate and shared section by clicking on this button. To create a plate section, the user needs to specify the type of section. For example, is it a regular plate section, a steel deck, wood panel, or diagonal lumbers? For a regular type, the user needs to assign material. We can select the material from this list. If the material is not available, we can click on this button and we can add the material to the model. The last step is to specify the thickness of the plate section. For example, 100 millimeters. We will rename the section and we click OK to validate. Now this section is available in the list. We click OK. If we switch the view to a solid view, now we can see the thickness of these plates. We can also change the size of the plates. By default, the plates have a dimension ratio of 90%. If you want to display the full dimension of the plates, we can set it to 100%. Now we can see the plates at 100%. One of the important parameters is the plate type, as it has an effect on the analysis. We have three plate types, including thin, thick, and membrane. Thick type plates usually give better results. The membrane type only has axial and shear deformation, and the thin type does not have any transverse shear, whereas the thick type does have transverse shear. If we were to compare, usually thick type plates give overall better results than thin type plates. Membrane is typically used internally to model diaphragms. When we activate diaphragms in the surface loads, the software internally will use membrane plate elements to model the effect of the diaphragm. Next on the right, we find a weight modification factor. We can adjust the thickness of the plates to calculate the self-weight if needed by specifying this factor. Below that, we find the stiffness modification factors. The properties of the plates used during the analysis may be modified for each plate. It is possible to factor the membrane, NX, NY, and VXY, the bending, MXX, MYY, and MXY, and the transverse shear, VXZ and VYZ stiffnesses. These factors only apply to stiffness. They have no direct influence on the stress calculations except on hyperstatic structures. In the offset section, the user can specify the alignments. By default, the plates are aligned to the center of the plate. But the user can also assign them to the top or the bottom. The user can change the coordinate system from internal to global. When the global coordinate system is selected, the user can specify a value of the offset along X, Y, and Z. In the geometry section, we find some useful information including the total area of the plate and the total weight. The last parameters are the connectivity. We find here all the connectivity joints for the plates, and the user can click on this button to inverse the connectivity. That's it for this video. Thank you for watching, and catch you in another one of our webinar series videos.